When you first learn about logs, it is easy to think the job ends once the events are collected and stored, because having data feels like having control. The reality is that logs become valuable only when you can interpret them, connect them to decisions, and communicate what they mean to people who own risk. In this episode, we are going to focus on building log analysis and reporting that connects identity and access management, IAM, events to business risk, because identity activity is one of the clearest signals of how trust is actually being used inside an organization. A successful login, a privileged role assignment, a failed authentication spike, or a sudden change in account recovery settings can each represent a different kind of risk, but the risk is not fully understood until you connect the event to what it could impact. Business risk is about consequences, such as data exposure, financial loss, service disruption, regulatory penalties, and loss of customer trust. Your goal as an architect is to design analysis and reporting that translates technical identity events into risk language that helps leaders and responders act. By the end, you should be able to explain how to structure IAM log analysis, how to choose meaningful metrics, and how to produce reports that drive decisions instead of producing noise. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful way to start is to recognize that IAM events are not just security trivia, because they represent the flow of access in the organization. Every time someone authenticates, requests access, receives a privilege change, or fails an access check, the system is expressing a trust decision. Trust decisions are where business risk concentrates, because access is the pathway to sensitive data and high-impact actions. If you cannot see and interpret those decisions, you are effectively running the business blind to how its most powerful control is behaving. This is also why IAM logs have dual value. They support rapid incident response when something suspicious happens, and they support governance and risk management even when nothing is on fire. For beginners, it is important to understand that log analysis is not about collecting interesting events for their own sake. It is about answering questions like whether access is being used appropriately, whether privileged activity is under control, and whether the organization's risk exposure is shrinking or growing over time. Connecting IAM events to business risk means you link identity activity to assets, processes, and outcomes, so the organization understands what a technical event could cost. That translation is what turns logging into a business control. To connect IAM events to business risk, you need a simple model of what business risk is made of. Risk is often described as likelihood times impact, meaning how likely something is to happen and how bad it would be if it happens. IAM events can influence both sides of that model. A spike in failed logins might increase the likelihood of an account compromise, while a privileged role assignment increases potential impact because the account can now do more damage if compromised. A service account token being used from an unusual system can suggest elevated likelihood of misuse, and the business impact depends on what that service can access, such as customer records or production configuration. This is why analysis cannot stop at event counts. It must interpret what the events mean in context. Context includes who the identity is, what systems it touches, what data is involved, and what operations could be affected. For beginners, the key is to see that technical events and business risk are not separate worlds. The technical event is the signal, and the business risk is the consequence that signal could lead to. Good reporting makes that relationship visible and actionable. A core architectural decision is to define the kinds of IAM events that will be analyzed as first-class signals, rather than treating everything as an undifferentiated stream. Some event categories are inherently high signal for risk because they represent control changes, such as group membership changes, role assignments, policy modifications, credential resets, and changes to MFA settings. Other event categories are high volume but still essential because they show access usage, such as authentication successes and failures, session creation, token issuance, and authorization denials. The goal is to build analysis that handles both types without drowning. High-signal events can often be analyzed individually and reviewed quickly, while high-volume events require aggregation, baselining, and correlation. A beginner mistake is to focus only on rare events because they feel important, while ignoring patterns in common events that reveal slow compromise or misuse. Another mistake is to focus only on high-volume metrics because they are easy to chart, while missing the governance story told by control change events. A balanced analysis program treats control changes as risk-altering events and treats access usage as risk-exposing behavior. This balance is what allows reports to show not only what happened, but what changed in the organization's risk posture. Before you can analyze meaningfully, you need normalization, which means making events comparable across systems so you can interpret them consistently. Different systems describe identity events differently, using different field names, different identifiers, and different formats for the same concept. If you try to report directly on raw, unnormalized logs, your analysis will be brittle and confusing because the same event type will look different depending on where it came from. Normalization is the process of mapping events into a consistent schema that includes stable actor identifiers, event type, action, target resource, outcome, timestamp, and context such as source system and session identifier. This does not require a single perfect standard, but it does require discipline and documentation. For IAM events, stable identity identifiers are especially important because usernames and email addresses can change, and service identities can have different naming patterns. Normalization also supports correlation because it allows you to link a login event to a subsequent privileged action even if they were logged by different components. For beginners, the key point is that analysis quality depends on event quality and consistency. If your event fields are inconsistent, your conclusions will be inconsistent, and inconsistent conclusions cannot drive confident business decisions. Once normalization is in place, the next requirement is enrichment, which is how you connect an identity event to business meaning. Enrichment means adding contextual data such as the criticality of the system, the sensitivity classification of the data involved, the business owner of the application, and the privilege tier of the identity. Without enrichment, a report might tell you that an account was added to an administrative group, but it will not tell you whether that group controls a test environment or a production environment that supports revenue operations. Enrichment also includes identity attributes like whether the actor is a human user or a service identity, whether the account is privileged, and which business unit owns it. Another important enrichment element is mapping resources to business processes, such as linking a database to a customer onboarding process or linking an application to payroll operations. This mapping is where IAM events become business risk signals, because you can say not only that access changed, but that access changed for a system that supports a specific business function. For beginners, this is the moment where technical logging becomes useful to non-technical decision makers. The architecture work is building and maintaining the mapping tables and ownership data that make enrichment possible and trustworthy. Analysis itself should be built around a few dependable patterns rather than around random dashboards, because the goal is to answer recurring questions consistently. One analysis pattern is baseline and anomaly detection, where you learn what normal authentication behavior looks like and then flag deviations that may represent compromise. Another pattern is sequence correlation, where you look for suspicious chains such as credential reset followed by MFA change followed by privileged access. A third pattern is privilege hygiene analysis, where you track how many privileged accounts exist, how often privileges are elevated, and whether privileged access is being used appropriately. A fourth pattern is access review support, where you use logs to provide evidence for why access exists and whether it is actually used. Each of these patterns ties directly to business risk because they detect likely compromise, identify control changes that raise impact, and reveal governance drift that increases exposure over time. A beginner mistake is to treat analysis as a one-time build of a dashboard, but strong analysis is a program that evolves with threats and business changes. Architects design analysis patterns that remain meaningful across systems and that can be explained clearly to both responders and leaders. The more explainable the analysis, the more likely it will drive action. A major part of connecting IAM events to business risk is translating technical severity into business impact, and this translation requires clear risk tiers. For example, The same event type can have different business significance depending on what it touches. A failed login might be low risk for a low-value application, but it can be high risk for an account that can approve payments or administer production systems. A service token being used outside its normal time window might be moderate risk in a lab environment, but severe risk in an environment that stores regulated data. Risk tiering means categorizing identities and systems based on business criticality, data sensitivity, and privilege level, then using those categories to interpret events. This allows reports to state that a privilege change occurred on a high-impact system or that repeated authentication failures targeted a privileged identity. Risk tiering also improves alerting and prioritization because responders can focus on events that could cause the most harm. For beginners, it is important to see that not every suspicious event deserves the same urgency, and urgency should be tied to potential consequence. When reports communicate risk tier clearly, business leaders can allocate attention and resources effectively rather than reacting to whatever looks scary in a technical feed. Reporting is where the analysis becomes a decision tool, and decision tools must be designed for the audience. A security operations audience needs detailed timelines, correlation identifiers, and technical context that supports triage and containment. A governance and risk audience needs trends, exceptions, and clear statements about exposure, such as how many privileged accounts exist, how often access is elevated, and whether access reviews are being completed. Executives need concise indicators tied to business outcomes, such as how identity-related incidents could affect customer data, revenue operations, or compliance commitments. If you present the same report to all audiences, it will satisfy none of them. Architects therefore design multiple report views built on the same underlying normalized data and analysis logic. This prevents the common failure where operational teams and executive teams have completely different numbers because they are looking at different data definitions. Another important reporting design principle is consistency over time, because trend analysis requires stable definitions of metrics. For beginners, the takeaway is that reporting is not decoration. It is communication, and communication is part of control. If the report cannot be understood by its intended audience, it cannot drive risk reduction. To avoid flooding analysts, reporting must emphasize prioritization and summarization rather than raw volume. High-frequency events, such as routine authentication successes, are usually not report-worthy individually, but they can be report-worthy as trends and distributions, such as login volume shifts, unusual access times, or geographic anomalies. High-impact events such as privilege assignments and policy changes should appear prominently with clear context and ownership, because these are the events that can quickly change risk posture. A common beginner mistake is to include everything because it feels thorough, but thoroughness without focus becomes unusable. Another mistake is to produce a long list of events without classification, forcing humans to determine priority manually. Good reporting uses categories, risk tier labels, and short summaries that explain why an event matters. It also supports drill down, meaning that if someone needs the raw details, they can access them, but the top-level report remains readable. This design approach respects the limited attention of analysts and decision-makers. It also supports rapid investigation because investigators can start from a prioritized set of signals rather than searching a haystack. The architectural goal is to make the report a map, not a dump. IAM analysis should also explicitly address non-human identities because service identities can create significant business risk and are often poorly governed. Service identities can act continuously, can access many systems, and can be exploited quietly if their credentials leak. Reports should therefore include service identity inventory metrics, such as how many service identities exist, which ones have privileged rights, and which ones have not been used recently. Dormant service identities are a risk because they may be forgotten and therefore unmonitored, yet still active. Another reporting focus is unusual service behavior, such as a service accessing resources outside its normal scope or operating from an unexpected environment. This requires enrichment that maps services to applications and business owners so that responsibility is clear. Without ownership, risk becomes unassigned, and unassigned risk is rarely reduced. For beginners, it is important to understand that IAM is not only about employees logging in. It is also about automation and integrations, and those identities can be some of the most powerful in the environment. Connecting service identity events to business risk means showing which business processes could be impacted if a service identity is misused. Another essential link between IAM events and business risk is the relationship between access changes and subsequent outcomes. For example, a privilege grant followed by sensitive data access is a stronger risk story than a privilege grant alone. Similarly, repeated authentication failures followed by a successful login and then an export event is a clear sequence that suggests compromise and potential data loss. Good analysis tracks these sequences by correlating identities, sessions, and resources over time windows that reflect realistic attacker behavior. This is where logs become narrative evidence rather than isolated points. The narrative can then be reported in a way that supports action, such as recommending containment steps, initiating access review, or triggering incident response escalation. A beginner mistake is to treat logs as independent events and to miss the sequence, which leads to underestimating risk. Another mistake is to assume every sequence is malicious, which can cause overreaction. The architect's role is to design correlation logic that is informed by threat behavior and tuned to the environment's normal patterns. When done well, sequence-based reporting creates a strong bridge between technical signals and business consequence, because it shows plausible paths from access to impact. Metrics are the language of reporting, and they must be chosen carefully to avoid misleading conclusions. A metric like number of failed logins can be useful, but it can also be misleading if it increases simply because the user population grew or because a system changed login behavior. Metrics must therefore be normalized, such as failures per active user or failures per hour, and they must be interpreted with context. Other useful metrics include time to revoke access after termination, number of privileged role assignments per month, percentage of privileged access that is time-bounded, and number of policy changes affecting sensitive systems. These metrics connect directly to business risk because they reflect control strength and potential exposure. For example, long delays in revocation increase risk of unauthorized access, while frequent policy changes without review can increase misconfiguration risk. Metrics should also support continuous improvement by showing trends over time, such as whether privilege creep is being reduced. A beginner mistake is to chase vanity metrics that look impressive but do not drive action. A good metric should support a decision, such as whether to adjust access workflows, strengthen approvals, or invest in automation. In architecture terms, metrics are part of the control loop that helps the organization improve. Because analysis and reporting can influence real decisions, they must be accurate and trustworthy, which means the program needs validation and governance. Validation includes checking that log sources are complete, that event fields are consistent, and that correlation logic produces correct results. Governance includes defining ownership for reports, defining who can change metric definitions, and documenting how risk tiers are assigned. If metric definitions change frequently without transparency, leaders will lose trust and stop using the reports. Governance also includes ensuring that reporting does not expose sensitive personal information unnecessarily, because logs can contain identity details that should be protected. Another governance element is ensuring that reports are actionable, meaning they feed into workflows for remediation, such as triggering access reviews, opening investigation cases, or initiating privilege cleanup. Reports that do not connect to action become passive information that decays over time. Architects therefore design reporting as part of a broader risk management process, not as a standalone display. For beginners, it helps to understand that trustworthy reporting is a product of disciplined definitions, consistent data, and clear ownership. Without those, log analysis becomes opinion rather than evidence. Finally, the most valuable outcome of connecting IAM logs to business risk is the ability to prioritize risk reduction work rationally. When reports show that privileged access is expanding, that service identities are unmanaged, or that access revocation is slow, leaders can invest in improvements that reduce exposure. When reports show that certain systems experience frequent suspicious authentication patterns, security teams can strengthen authentication and monitoring where it matters most. When reports show that sensitive data is being accessed in unusual ways, data owners can adjust controls and workflows. This prioritization is what makes log analysis a strategic capability rather than a reactive one. It also supports communication across teams because the report provides a shared language of risk that ties technical events to business outcomes. For beginners, it is important to see that security is often limited by attention and resources, so prioritization is essential. Log analysis and reporting are how you decide where to spend effort for maximum risk reduction. If you cannot connect events to consequence, you cannot prioritize effectively. Architecture is about making that connection clear, repeatable, and trusted. Building log analysis and reporting that connects IAM events to business risk is about turning identity activity into evidence-based decision-making rather than leaving it as raw technical noise. The work begins with consistent event normalization and reliable identity attribution so events can be correlated across systems and time. It becomes meaningful through enrichment that links identities and resources to business criticality, data sensitivity, and ownership, allowing technical events to be interpreted as potential consequences. Effective analysis uses patterns like baselining, correlation, and privilege hygiene to detect likely compromise, highlight control changes, and reveal governance drift that increases exposure. Reporting then translates those signals into audience-appropriate views, prioritizing high-impact events and trends while avoiding information floods that paralyze analysts. Metrics are chosen to drive action, not to impress, and governance keeps definitions stable and trustworthy over time. When designed well, this capability supports rapid investigation and long-term risk reduction by making it clear how identity events can lead to real business harm. The deeper lesson is that IAM is a trust system, and log analysis is how you measure whether that trust is being used safely, so the organization can manage risk with clarity instead of guessing.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.